Another CSIR problem. Here one Lagrangian is given and they are asked to find out the type of system. Sometimes just by looking into the Lagrangian we will not get sufficient information. Here you see for this Lagrangian we will not get much information. So what we do? We find out the corresponding Lagrange's equations of motion. So we get the equations of the system in a motion. So we can more easily identify the system. So what is the Lagrangian here? It is equal to 1 by 2 mx dot square minus 1 by 2 kx square minus kx x dot t. So the generalized coordinate is x. Then d by dt of dou L by dou x dot minus dou L by dou x equal to 0. That is our equations of motion. Then what will be this value? D by dt of dou L by dou x dot, that is m x dot. And here also x dot is there. Therefore minus k x t minus dou L by dou x. So that will be plus k x. And here also there is a x time. So we get plus k x dot. That is mx double dot minus k x dot t minus k x plus k x plus k x dot t equal to 0. Here k x dot t, k x dot t cancel and kx minus kx will cancel. So what we get? We get mx double dot equal to 0. What is this double dot? That is d square by dt square of x. That is nothing but acceleration. That is ma equal to 0. Here we know the particle mass never be 0. This is not equal to 0. Then what will be the 0? A will be equal to 0. That is, there is no acceleration. In the option they given about harmonic oscillator and free particle. So what is the acceleration of a harmonic oscillator? Suppose I am taking a simple harmonic oscillator. This is mass m and this is its mean position and it is oscillating about this axis. Okay, and you can see when this mass is at this end, its velocity will be equal to 0. And the velocity will be maximum when it is at the center. So in this motion, its velocity is changing. Therefore, acceleration is not equal to 0. So whatever may be, if even it is a damped harmonic oscillator or undamped harmonic oscillator, there will be acceleration. But here in the equation of motion, we got acceleration of the body is 0. That means this is corresponds to free particle. Free particle means there is no force acting on a particle. That is, you know, F equal to ma. If there is no force, that is F equal to 0, then m will not be equal to 0. Then what will be the 0? Acceleration a will be equal to 0. So this is the Lagrangian corresponds to a free particle.